Moving zeros to the end of an array looks like it needs a slow and tedious approach, but there's a two-pointers trick that makes it much faster. We're given an array of numbers and we need to move all the zeros to the end of the array while preserving the order of the non-zero elements. For example, if we have an array with zeros, ones, and other numbers, we need to rearrange it so that all the zeros are at the end and the non-zero elements are in their original order. Let's consider an array with the numbers 0, 1, 0, 3, and 12. One way to solve this problem is to use a brute force approach, where we iterate through the array and swap each zero with the next non-zero element. However, this approach is too slow, with a time complexity of n squared, making it impractical for large arrays. The key insight here is that we can use two pointers to keep track of the position of the next non-zero element and the current element we're processing. We start by initializing two pointers, one at the beginning of the array and one at the beginning of the array. Then, we iterate through the array, and whenever we encounter a non-zero element, we swap it with the element at the next non-zero position and increment the next non-zero position pointer. Let's walk through an example to see how this works. We start with the array 0, 1, 0, 3, and 12. We initialize our two pointers and then we start iterating through the array. When we encounter the first 0, we don't do anything, but when we encounter the 1, we swap it with the element at the next non-zero position, which is the 1 itself. Then, we increment the next non-zero position pointer. We continue this process until we've iterated through the entire array. You'll recognize this pattern when you need to rearrange elements in an array based on certain conditions, and you can use two pointers to keep track of the positions of the elements. The time complexity of this optimized solution is linear, and the space complexity is constant, making it much more efficient than the brute force approach. Try the next problem that involves rearranging elements in an array, and see if you can apply the two pointers trick to solve it efficiently. Don't forget to subscribe and ask questions in the comments.